In the last two tutorials, we were looking at how to calculate the present value of an annuity and the future value of an annuity. Now what I want to do is show you how to calculate the annuity if you happen to know what the present value is and what the interest rate, the number of periods, happens to be. And this can be very useful. For example, suppose you borrow $20,000 to buy a car, and you decide to take out a 48-month car loan. What's your car payment going to be? Well, your car payment is an annuity, and we want to solve for the annuity. And here's what it looks like. So let's say solving for the annuity. Well, basically we go to the equation we had before. We had a present value equation. Present value equals the annuity times the present value annuity factor. And so just with a little simple algebra, we can divide both sides by the present value annuity factor, and we get that the annuity is going to be equal to the present value divided by the present value annuity factor. So let's look at an example. Suppose you borrow $20,000 for a car, so a $20,000 car loan. And suppose the interest rate is 6%, but we're going to look at compounded monthly. Let's see what we have here. And we're going to talk about a 48-month car loan. Well, what's our monthly interest rate? Our monthly rate is going to be equal to the 6% divided by 12, because there are 12 months out of the year. So it's going to be 0.5% per month. And so if we wanted to use the formula we had before, we could just solve it this way. A equals 20,000 is our present value, the amount we borrow right now, divided by, and we said the formula was 1 minus the present value factor, so this is going to be 1 over 1.005 raised to the 48th power, and then you have to divide by the interest rate. So I'll divide by 0.005. Okay, I'll put that in brackets so you can see what we have. And let's do it on the calculator. 1.005, raise that to the 48th power, and we get something. And then we want to flip it over, because this is just 1.005 to the 48th power. So hit the 1 over x key, and so that's what this is. Let's add it to 1. Let's make this negative and add it to 1. So essentially we're subtracting it from 1. And let's divide by the interest rate, 0.0005. So that's our factor here, 42.5803, and if we flip this over, we can multiply it by 20,000. Okay, 20,000 divided by this is the same as 1 over this times 20,000. So I'm going to hit the 1 over x key again, times 20,000, and we get a car payment of $469.70. And again, we can do this using the time value of money functions. Let's see if we did it correctly. I'm going to clear my time value of money functions. 48 months interest rate is 0.5. Again, you don't have to put decimals in the calculator. You put 0.5%. Present value is 20,000. And we want to compute the payment, and we get $469.70. Let's do one more example. Let's look at the future value of an annuity. So the same thing holds true here. Future value equals the annuity times the future value annuity factor. And so that means that $A is just going to equal the future value divided by this future value annuity factor. And so let's look at an example. Suppose you'd like to have $1 million in your bank account. So you'd like to have $1 million in your account in 20 years. Let's say the interest rate is 7%. Let's ask ourselves, how much do you need to save each year in order to reach that goal? So what do we have here? Well, we have the future value is $1 million, the interest rate is 7%, and the number of periods is 20 years. So using this formula, we get 1 million divided by, and the future value factor is the future value factor, not the future value annuity factor is the future value factor minus 1 divided by the interest rate. So it's going to be 1 plus 0.07 raised to the 20th power minus 1 all divided by 0.07. And I'll put that in brackets there. So let's work that out. And then we'll use the financial calculator to check ourselves. 1.07 raised to the 20th power minus 1 divided by 0.07. So our factor, this number in the brackets here, is 40.99549, etc. So I can flip that over. Whoops, I'm sorry, the wrong key. Flip that over, the 1 over x key, times 1 million. Oops, I did something wrong. Let's what did I have? Let me do that again. 1.07 raised to the 20th power minus 1 divided by 0.07. Okay, so that's our factor. And I want to flip that over and I want to multiply it by 1 million. That looks better. So it looks like we have $24,392.92. Okay, so if you save this amount of money, you'll have $1 million in your account, assuming that you can earn 7% a year for this 20-year period. Let's check ourselves. Let's try the time value of money functions here. Clear them. We know that n equals 20. We know the interest rate is 7%. In this case, we know the future value, not the present value. We know the future value is 1 million, and we simply compute our payment, and we get $24,392.92. So if you'll save this amount of money for 20 years, if you earn 7%, you'll have $1 million in your account.